It went on my face.
While pushing off the wall, the body should be underwater and facing the bottom of the pool. The hands should be together and in front of the body. The biceps should be pressed against the ears, the head stationary, and perpendicular to the body. This is called the streamline. The legs will follow with their kick. While in streamline position, the swimmer is forced off the wall by their legs, using their quadriceps and hamstrings. The sleeker the body is, the less drag produced. If the swimmer does not use the correct form of the streamline, a greater drag force is applied to the body. This will cause the swimmer to slow down and lose acceleration gained by pushing off the wall. Linear motion is shown when the rate of change of the position of an object increases when the swimmer applies more pressure on the catch and push phase of the stroke. Movement occurs in the direction opposite than the applied force. Once the swimmer initiates the pull by rolling their hips and utilizing the stabilizers of their torso, they push the water backwards, which results in forward motion. Once the one arm finishes the push phase and starts to recover, the opposite arm begins to accelerate.
Angular motion is produced by the application of a force acting at some distance from an axis by choice. This produces change in angular motion. By initiating the roll with the hips, the swimmer is using torque. The swimmer's hips initiate the catch phase of the stroke because by rolling your hips, you are twisting your body the opposite way of where your body would lie while completely relaxed.
When swimming freestyle, several levers are used. One is the first-class lever. This happens when the arms are at opposite ends of the body. One arm is starting the catch and the other is finishing the stroke. Another is the third-class lever. This happens when the bicep bends and extends to initiate the catch phase of the stroke.
Newton's first law of motion states that an object in motion will stay in motion unless acted upon by a force. In swimming, water produces a resistive force that requires the swimmer to power through propulsive forces in order to move forward. Newton's second law states that force equals mass times acceleration. In swimming, the force produced by the swimmer is equal to the mass of the swimmer multiplied by the acceleration of the swimmer in the water. Newton's third law states that for every action there is an equal and opposite reaction. In swimming, we can relate this to the standard hand and arm stroke, when the hand travels downward in the water and then backwards to propel the swimmer forward. In creating an equal and opposite reaction, the swimmer is kept afloat and propelled forward.
The muscles used are biceps, triceps, deltoids, rectus abdominis, quadriceps, and hamstrings.